What's up guys, and welcome to this video. This video is on kinematics. In the first video we went over some definitions and then we spoke about distance versus displacement, and now we're going on to speed versus velocity. But before we touch on that, I actually want to go and speak a little bit more about distance versus displacement. Okay, and I just want to ask some questions basically. Okay, so can distance, my handwriting, sorry guys, can distance be equal to 0? Can displacement be equal to 0? Can distance be greater than displacement? Can displacement be greater than distance? Okay, so let's answer some of these. Okay, so can the distance be equal to 0? So if a person is at the start of a race and they are not moving, distance can be equal to 0, so that is true. Okay, can displacement be equal to 0? Well, we already spoke about the track race where you start and end at the same place, and we end up with a displacement. Our start is equal to our end, and so the displacement does come out as being 0, so that can be true too. Okay, so can the distance be greater than the displacement? Okay, we actually did an example, but let's just do one. Well, yeah, we can work with this example we had right here. If we go around the track, let's say the track is 500 meters, the distance is equal to 500 meters, and the displacement is equal to 0, so distance can be greater than displacement, so that is true as well. And lastly, can the displacement be greater than the distance? Okay, so if we continue with this story right here, if we end at the finish line, okay, the displacement can never be greater than the distance, so this is false. We cannot have that happening. The distance can never be greater than the displacement, and the next question I'm going to ask is, can the distance be equal to the displacement? Okay, and that would be this case right here. If we look at distance, let's look at distance in blue. The distance is equal to, let's say, 500 meters, and if they ran it straight, then their displacement is also equal to 500 meters right. Okay, so that can be true. Okay, so these are the kinds of tricky multiple choice questions that you can get. Well, they're not actually too tricky, but yeah. Okay, so moving on to speed versus velocity. Okay, I'm going to keep the same color code. So blue for, you guessed it, scalar, and red for, was it red? Yeah, red for vectors. Okay, so let's get some definitions out of the way. So what is speed? Okay, so speed is the rate of change of distance. Okay, and what is velocity? Velocity is the rate of change of displacement or position. Let's say position. Well, let's actually say displacement / position. Okay, so we already know that speed is a scalar, and if you look at the definition, it is the rate of change of distance, which was also a scalar. And surprise, velocity, which is a vector, is linked to other vector quantities, which are displacement and distance, both of displacement and position, both of those are vectors. Okay, so what does the rate of change mean? Okay, so you guys probably have come across this, but that just means the change or the delta or the difference. So if we want to do speed, I'm sure everyone knows speed equals distance over time. Okay, but what we're actually trying to say is that speed is equal to the change in distance over the change in time, right? There needs to be a change in time. So if we look at the top running position, at this point, he is at a distance of 0, and the time is equal to 0. At this point, they are at a distance equal to 500 meters. Okay, so and at a time of, let's say, 15 seconds. Okay, whereas if we look at velocity, okay, so velocity is equals to, okay, so change in displacement over change in time. Okay, don't get confused by this S. This is displacement. This is our symbol for displacement. So velocity is the change in displacement over the change in time. Okay, so let us get into a question so that we can use these equations and see their differences. Okay, so I think I did questions in, what color did I do questions in? Questions in orange, cool stuff. So, example. Example 2. Okay, so let's say Megan is walking home along a straight path. Okay, the length of the path is 5 kilometers, and it takes her, let's say, 45 minutes to get home. Okay, she then turns around immediately and goes back to school. Okay, don't ask me why. She just felt like a quick stroll between classes, I guess. Okay, so question 1 says, what is the average what is the average speed? What is her average speed? And the next one, what is her average velocity? Okay, so the first thing, let's say you don't fully understand what's happening, let's draw a nice picture. Okay, so my picture looks something like this. She's at school, and then some 5 kilometers away home. Okay, see. So we have home. Then we also know that, okay, so what is our average speed? Let's say both of these are for the entire distance. Let's say for the entire journey. And this one also for the entire journey. Okay, so what does her journey look like? So let's do that. So she starts at school, then she walks. She walks all the way home. Okay, at this point, t is equal to 0. Okay, I'm going to say that's 0. So that's when she leaves. Then she gets home. At this point, t1 is equal to 30 minutes. Okay, and then she turns around and goes back to school. Okay, and at this point, t is going to be equal to 60. So t2 is equal to 60. Okay, that's just because it takes her 30 minutes to walk to home, and then from home to school, it'll take the exact same time. Okay, so the question is, what is her average speed? Okay, so we said speed is equal to change in distance over change in time. So first of all, we need to figure out what my SI units are. Okay, SI units are meters. So I need to convert this 5 Okay, so remember she also does 5 kilometers there and then 5 kilometers back. So in total, she's done 10 kilometers. Her distance traveled in blue is 10 kilometers. 10 and kilometers to meters is times 10 to the 3 meters. Okay, what's her time? So her time is the total time taken, which is 60 minutes, and we want that in seconds, so we multiply that by seconds. Okay, let's actually just speak about these units quickly. Speed has got units of meters per second, and the same with velocity, we have meters per second. Okay, so those are our units that we're looking for. So what we have is, if we plug that into our calculator, we have 10 times 10 to the 3 over 60 times 60 seconds. And we get an average speed of 2,78 meters per second. Okay, that is the final answer. Okay, this can also be written as meters seconds to the minus 1. Okay, either one of those is fine, whatever you guys like. Okay, I don't know if you can see that blue. 2,78 meters per second. Let's do it like that for now. Okay, so remember, speed is a vector. Speed is a scalar. So that is our final answer. We don't care about a direction. Okay, now we want to go over the velocity. Okay, so velocity is change in displacement over change in time. What is the change in displacement? Okay, so velocity equals change in displacement over change in time. What is her change in displacement? She starts and ends school at the same place. So her change in displacement is 0 over 60 times 60 seconds. 0 over anything is 0 meters per second. Okay, and in this case, 0 meters per second, we don't really care about a direction because it has no effect. Okay, but let's change the scenario a little bit. And let's say that she walks to a shop in the middle, which is half the distance away, so 2,5, and it takes her 45 minutes to do that. Okay, so if we go over that, so to get home, okay, let's say it takes her 20 minutes to get from home to the shop. So this time her path would look something like this. She goes from school, goes home. At home, she gets her wallet or whatever, and it takes her 30 minutes. That's fine. And then she goes to the shop where she ends her journey. Okay, and it takes her 20 minutes. So T2 is going to be equal to a total of 50 minutes. Okay, so that's just 30 minutes plus 20 minutes. So T2 is 50 minutes. Okay, so we're going to do the same question. So distance, speed is equal to change in distance over change in time, which is equal to, okay, so what is the distance she's traveled? It's this whole path. So that's the full 5 kilometers plus another 2.5. So that's 7.5 kilometers. I want to convert that to meters, so I times it by 10 to the 3 over the time it took her. Okay, the total time. So the total time is going to be 50 minutes. So 50 times 60 seconds. Okay, so if I put that into my calculator, I end up with 2.5. What a nice number. 2.5 meters per second. Again, it is a scalar, so that is my final answer. Now I want to figure out the velocity. Okay, so the velocity is my change in displacement over my change in time. What is my change in displacement? Okay, I started at this point 0. I'm taking that direction as being positive. I'm taking right as being positive. I start here and I end here. Okay, so the distance between these 2 points is 2,5 kilometers. Okay, I just figured that out. This is 2.5 and this is 2.5. Okay, so my change in displacement is a positive. I'm choosing right as being positive. A positive 2,5 times 10 to the 3 meters over the time it took her. It took her the full time, okay? Takes her the full time. So that's 50 times 60 seconds. So if I put that into my calculator, I get a velocity of 0.83 meters per second, and I'm going to take right. I'm going to say this came out positive, so that means it's 0.83 meters per second right. That is my average velocity. Okay, so you need to take into account the direction. Okay. Okay, with that being said, let us quickly just look at the same thing we did before. So we have distance and we have displacement. Okay, so again, just not distance, sorry. So we have speed and we have velocity. Okay, so if we're looking at speed, it is dependent, so it depends on the path. Okay, if we look at velocity, it is independent of the path. Okay, number two. Okay, again, speed is a scalar, right? So scalar, therefore, always positive. Okay, while velocity is a vector, so therefore can be positive or negative. For example, if our school was here, if our shop was here, then and 2.5 kilometers away, then her displacement, taking right as positive, would be minus 2.5 kilometers. Okay, because she would end up to the left of where she had started originally. So then her velocity would be the negative 0.8, what was it, 0.83 meters per second, or 0.83 meters per second left. Okay, so that's for this scenario right here where the shop is to the left of the school. Okay, then the last point is we obviously, for a scalar, no direction needed. Okay, so a vector, we must give a direction, must always give a direction. Okay, so yeah, I think I'm going to end it there so that we can focus on graphs in the next video. Yeah, so we're going to be drawing some displacement time graphs. Actually, let me just cover one more thing. Instantaneous velocity. Okay, so this is something that confuses everyone, and there's absolutely no reason. So let's go over it. No, that's not right. Let's see. Oh, it is right. Sorry, my spelling is really bad. Okay, instantaneous velocity. Okay, so what is an instantaneous velocity? Okay, so instantaneous velocity is it's when we use a very small change in time or small time interval. So for example, if we have a person, sorry, okay, let's actually use a car because I've used the person analogy a lot. We have a car in a race and we want the instantaneous velocity, but we're looking at a time of 0 and then at a time t equals 0.5. So it's a very small time difference, okay? But otherwise, another situation is what we can say is that over a long period of time, it can be the average velocity where the time period is large. So for a large time period, okay, so for a large time period, the instantaneous velocity is equal to the average speed with a direction. Okay, so very important. With a direction. Okay, so we're mostly going to be looking at these situations where we speak about large time periods. Okay, so for example, let's have our classic track. We have a track, but this time it is a motor vehicle track. Okay, so we define that upwards direction as being north. Okay, and we can actually label this as an example. Okay, we said the track is 2 kilometers long, and it takes the car 1.5 minutes to complete the circuit. Okay, what is the instantaneous velocity at A, B, C, and D? Okay, so this is point A, this is point B, this is point C, and this is point D. Okay, so if I were to draw the car at point B, it would be going like this, and it's going in that direction. At point C, the car is going in that direction, and at point D, it's going in that direction. And obviously at point A, it is going in that direction. Okay, so what did we say? Instantaneous velocity for a long time period, or a large time period, it is equal to the average speed. So let's start off by calculating the average speed. So the speed is equal to my change in distance over change in time. So my distance is 2 kilometers, so that's 2 times 10 to the 3 meters over 1.5 minutes, so times 60 seconds. So that comes out as, if I put it into my calculator, that comes out as 22.22 meters per second. So that is my average speed. Okay, so now I just need to give it a direction. So at A, the instantaneous velocity is equal to 22.22 meters per second. And at A, what direction is it going? North. Cool stuff. At B, what direction is it going? 22.22 meters per second. At B, it is going north. We're going to be going west. Okay. At C, we have 22.22 meters per second. What direction is it going at? Okay, so obviously, if we draw a compass, we have north, south, east, west. So if it's going downwards, which it will be, then the direction is south. And at D, our instantaneous velocity is 22.22 meters per second, and it's going to the right, which would be east. Okay, so do not get scared by instantaneous velocity. There's nothing really too tricky or scary about it. Yeah, so don't get scared. Okay, yeah, so this is where I'm going to call the video. And in the next video, we will be going over some graphs. And then eventually we will get onto accelerations and stuff like that. Okay, cool. Thanks for watching, guys. Hope you guys found this useful.